Okay, we want to go ahead and look at inductive and deductive reasoning. For some folks, this can be a little bit confusing, but the main thing is we're looking for patterns with inductive reasoning. We're looking at specific examples, trying to see what is the pattern, what's changing here, what's the next thing. So in this particular problem, we're looking at basically left side, right side, and asking ourselves what's changing? How is it going from one line to the next? On the left-hand side, we start with 1 plus 2. The next one goes 1, 2, and then 3. Okay. And then the next line is 1, 2, 3, 4. So it looks like we're just kind of adding the next number. What about the next line? Sure enough, 1, 2, 3, 4, 5. Makes sense then that the next line would be, you guessed it, 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, now what's it going to equal? Now we look at the right-hand side and look for the pattern over there. 2 times 3 over 2. Okay, so we got a fraction. Next one, also a fraction over 2, divided by 2. But this time, instead of 2 times 3, we have 3 times 4. So we kind of like went up one. What about the next line? Still divided by 2, but instead of 3 times 4, we go to 4 times 5, again, up by 1. And then from 4 times 5 over 2, we go up to 5 times 6 divided by 2. So sure enough, what do you think the next numerator is going to be? That's right. 6 times 7 divided by 2. All right, well, this is beautiful patterns, but does it make sense mathematically? Let's just check a couple of them. The first one, 1 plus 2 is 3, and then 2 times 3 is 6, and we divide by 2, and sure enough, I think that's actually 3. Sorry about that. And then 1 plus 2 plus 3. 1 plus 2 is 3, plus 3 is 6. 3 times 4, 12 over 2. Yes, again, that works. Let's jump down to the one we just made up. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 would be 15, plus 6 would be 21 over here. What's 6 times 7? Oh, that's 42. And then if we divide that by 2, sure enough, it is 21. So it really works. It's not only a cool pattern, it works. Now let's try another one. See if you get this. A little bit different. We're doing 1 times 8 plus 1. Yes, that would equal 9 because 8 plus 1 is 9. And then 12 times 8, that's 96. 96 plus 2, sure enough, that equals 98. And then they just keep going down and building this pattern like a pyramid. Okay, so take a look at what's going on over here on the left and see if you can figure out what the next line would be. What's that next number going to be? Notice the times part, the times 8, stays the same every single line. But then there is also a change right here. What's the pattern? What's going on from one line to the next? Can you predict the left-hand side of the next line? Okay, so what we're doing, we're taking that first number, we're just adding the next consecutive digit. So we're going to have 123,456. 123,456 is still going to be, like all the others, times 8. But this time, what are we going to add? The next consecutive number would be 6. Okay, so what about the right-hand side? Well, we start out with 9, then it goes to a 2-digit number, then a 3-digit, then a 4, then a 5. So we're getting bigger numbers, but notice how we're getting them. It goes from 9, then 9, 8, then 9, 8, 7, then 9, 8, 7, 6. It looks like we're going down. What would you predict the right-hand side of this next line would be? That's right, 987,654. You can trust me on this one. If you don't, go ahead and get your calculator. It actually works. Pretty cool stuff. All right, let's take a little bit different twist. This time we want to do one of these problems like you may have seen on Facebook. Looks like somebody has this magical knowledge or something. It's math. That's all that's behind this. All right, so let's look at 2 examples. This first one, we're going to multiply a number by 4, add 8, divide by 2, and subtract 4. And then we're going to figure out what our answer is. We're going to look for a pattern and then prove that it works no matter what number we start with. All right, so the first one we want to use is 2. So 2 times, let me get a marker here, and I'm going to use blue. So 2 times 4 is going to be 8. And then we're going to, let's see, 8 plus 8, 16. And then it says divide that by 2. So that's going to be 8. And then 8 minus 4 is, 4. Right? So my answer here was 4. Now it says try 5. All right, so we're going to do the same thing, go through all these steps again. So 5 times 4, and then add 8. And then we're going to divide that, 28 by 2, and get 14. Subtract 4. So final answer is going to be 10. All right, what about the next one? Well, it says 8 is my starting point. So 8 times 4, again, we're going to start there. It says add 8 to that, so that's going to take me up to 40. And then divide that by 2 and get 20. Oops, I don't know what happened there. Sorry about that. 20, and then 20 minus 4 would give me 16. Okay, so started with 2, got 4. Started with 5, got 10. Started with 8, got 16. Are you seeing a pattern? Well, the next step says write a conjecture. Look for the generalization that relates the result to the original number. So 2 going to 4, 5 going to 10, 8 going to 16. What could you do in each of those cases to get that answer? Put it in terms of n. What do you get? Well, if 2 goes to 4, 5 goes to 10, 8 goes to 16, I'm looking at doubling. So the way I would write that with n is 2 times n. I'm doubling it. I'm multiplying by 2. Okay, so here's where we start using some math again. But this time we're going to use deductive reasoning. We're going to use general principles of mathematics to prove that this actually works, no matter what the starting number was. Okay, so we're going to select our number, call it n. We're going to multiply by 4. So how do you represent that algebraically or mathematically? You put 4n. How do you add 8? You put plus 8. So far, so good, right? Now, divide this by 2. This is where it gets a little bit tricky for some of us. So take a minute and see if you can divide by 2 and simplify your answer. The important thing to remember is that you have to divide all of it. So it's the 4n divided by the 2. It's the 8 divided by the 2. And when you simplify the result, you get the 2n plus 4. Okay, now from that, I want to subtract 4. Okay, so I take that whole thing, I subtract 4, and my answer is going to be, let me move it down a little bit further. There we go. 2n plus 4 minus 4, the 4's cancel, and I'm left with, sure enough, the 2n, which proves my conjecture. All right, let's try another one. This is a little bit different. Similar idea, but I want to see how well you can do it. This time we're going to add 3, double the result, add 4, divide by 2, subtract the original number that's used. So go ahead and start with 5 and then 9 and 2 and see what your answers are. Okay, so what do I get if I do this? 5 plus 3, and then doubled is 16, then 16 plus 4 is 20, divided by 2 is 10. Subtracting the original number, I get 5. What if I start with 9? Well, 9 plus 3 is going to be 12. Doubled is 24. Adding 4 is 28. Divided by 2 is 14. And subtracting the original number is 5. Huh. So I started with 5. I got 5. I thought maybe I'd get back my number. But here I start with 9 and I get back 5 again. Let's try a third one. So 2 plus 3 is 5. Sorry, my pen's switching on me. 5 ago. And then we're going to double it, 10. Add 4. And divide by 2. and subtract the original number. Well, 7 minus 2 is, sure enough, 5. So it seems like the original number I start with doesn't even matter. My answer is going to be 5. That's what I would suspect my conjecture is. So I'm going to say if my original number is n, doesn't matter. My answer is going to be 5. All right, so let's go to proving it. Let me see if you've got this down. All right, so how could you go through this procedure? First off, selecting the number, that's basic. That's n. Adding a number, you can do that. Means plus 3, right? Now, think about doubling that number and simplify it. The important thing to remember is that we're going to double the entire amount. So I write 2 times the quantity, and remember that I distribute so that I get 2n plus 6. Now if I want to add 4, I'm just going to go ahead and add 4 and then combine some like terms and get 2n plus 10. Now what about dividing that value by 2? What does that look like when I've simplified it? That's right, we have to do it in parts. We have to do the whole thing. We have to divide the entire amount. So the 2n and the 10, both of them get reduced and we get n plus 5. So then my final thing is to subtract the original number. Well, the original number was n, so when I subtract it, sure enough, I get the 5 I suspected.